And welcome to the coding portion of Circular Linked List. So let's get started. The first thing we need to code is I just kind of created a package directory here. So I just created a package called linked list. And we need to create a first class, which we're going to call node, because that's what's going to store the value that we want to hold and the next reference. All right, so that means we need two fields, private integer value, and then private node next. Again, it's the value we're storing, and then the next reference, which is going to be the next node in the list. So we need to create a constructor, public node with two arguments, integer value, node next. And we're going to say this dot value equals value, this dot next equals next. All right. And then we just need our getter and setters. Normally there's shortcuts. I want to use IntelliJs, which is alt insert, if that's what you're using. And that generates the setter and getters for you. All right. So if you want to take a second, if you don't know what that is, or using like just a simple text editor that doesn't do that, go ahead and pause and copy this. All right. So the next thing we need is we actually need our circular linked class. So we're just call it circularly linked list. Okay. So in this class, we're going to have two fields. We're only hold the reference for the tail. We need private node tail. Then we need to we're just going to keep track of the size of the list. So private int size. Okay. So we don't need to define a constructor. It'll just have the default one. So the first method we're going to be using is the couple simple methods. We're just going to return the size, returning the size of the list. So we're just going to return size. All right, we're calling get size, and we're just returning the size. That's it. The next one is we want to check if the list is empty or not. So that's going to be a Boolean. We're going to call it is empty. So it's going to return true if it's empty, false if it's not. And the way we know that is if the size is 0, it's empty. Otherwise, it's not. So we'll return false. So return size equals 0. If the size is equal to 0, return true. Otherwise, return false. Okay. So far not so bad. So the next thing we're going to do is we're going to return the first element in the list. So we're going to say public integer first, and we have a null check. So if the list is empty, return null. Not a null check. We're just checking to make sure there are nodes in the list. Otherwise, if it's not empty, then we're going to return tail.getNext.getValue. Sorry. Yeah, so we're going to tail.getNext is the head node, so that's the first node in the list, and then we're getting its value. All right. So we're going to have the next one is going to be public integer last, where we're just getting the last node in the list. Again, we need to check to make sure the list is not empty. If it is, just return null. Otherwise, we're just going to return tail.getValue. All right. So we kind of got those out of the way. Those are the simpler ones. The next two are going to be adding to the beginning and adding to the end of the list. So let's do the first one. We're going to be adding to the beginning. Public int add first. And we need to pass in a value. So we're just passing in the value that we want this new node to hold. Okay. So first off, if we need to check to make sure it's not empty. If it is empty, then we're going to say tail equals new node value, and it's going to have a null next reference for now first, because we can't set that to, we need to set it to itself, right? So let me do this first. Then we're going to say tail.setNext tail. So because this is going to be the first element in the list, because it was initially empty, we need to set the tail's next reference to itself because it's the only one on the list. Otherwise, If it's not empty, we're going to say we're going to create new node. So node newest equals new node, the value we're passing in, and then its next reference is going to be tail dot get next. So we're saying this new node's, because we're adding it in between the tail and the head, this new node, its next reference is going to be what's currently the head. So tail dot get next is currently the head. And then we're going to say tail dot set next, and we're going to set that to the newest. So now the tail is still set to what was the head node. Now we need to set it to the current node, which is the new head. Okay. Last thing we need to do, increase the size. All right, so we're going to be doing the same thing for add last. It's argument of, we have a single argument, call it integer value. This one's very easy. It's like 2 lines for this one. The first thing we're going to do, add first, and we're going to pass in the value for this new node. Okay. So when this line is executed, now we have a new head node, right? With this new value we're passing in. So all we have to do now is say tail equals tail dot get next, and that's it. So tail dot get next is the head node, which is where the new node is. Now we're just saying the tail equals that. Have our last main operation, and that is removing the head from the list. And then we're going to return. Then we're going to return its value. So we need to have return type of integer. We're going to say remove first. And there's we need to have a couple checks first. So the first one is going to be, we can't remove anything if the list is empty. So if is empty, return null. Okay, that's that. And then we're gonna hold a reference value for the head node, and it'll make sense once we code the rest of this up. So we're gonna say node head. This is just local to this method. So node head equals tail dot get next, because that's the head node. Which, if the case that there's only one node, the head is just going to equal the tail. If head is equal to tail, so this means that there is only a single node in the list, the head is equaling itself. Basically, we're saying tail equals tail.getNext. So tail is just linking to itself. If that's the case, then we need, because we're removing it, so we're removing the single node in the list, we're saying tail equal null. And so now that's it. Okay, that's it for that one. So otherwise, meaning that there's 2 or more in the list, then we need to say tail dot set next, head dot get next. So let's make sure this makes sense. We're saying if there's 2 or more in the list, the tail dot, we're setting the tail's next reference, which is always the head, to the head local variable, its next reference. So we could just say tail.getNext.getNext, right? But that's kind of verbose. So we're saying we're like removing any reference to the current head. So the tail.setNext is the head's next reference. So we're like skipping over the head, okay? And then decrement the size variable, and we need to return. This is also why we kept the local reference for what was the head node, because we need to return its value. So head.getValue. Okay. So the last thing that we're going to code up is just a simple print list, so that whenever we test it here in just a minute, we'll be able to confirm that everything works. All right. So public void, just call it anything, like something like print list. That's what I'm going to call it anyways. So I'm going to have a check. If it's empty, we're just going to print out list is empty. Otherwise, I'm going to say just have a print ln traversing the circularly linked list. So we we need a node to start out with. So we're going to start out with the head node. So node equals tail dot get next. And we know the size, right? We've been keeping a variable that holds the size of the list. So you can just do a simple for loop. I mean, this is just for testing purposes anyways. So for int I equals 0, I is less than size, I plus plus. All right, or increment the size, or increment I. So we're going to print out system out dot print, so it doesn't go to a new line. I want to keep this all in one line. We're going to have a space. Then we're going to say node dot get value. And then we need to say node equals node dot get next. So we're just printing out, which now it's going to do in the same line, the value of the current node every iteration of this loop. Okay, and we need to say node equals node dot get next so that we can keep going through the list. All right, otherwise we would just print out the first node in the list however many times based on the size, right? So that's that. Okay. Hopefully this works, but we're going to test it. So in the main method, we are going to instantiate a circularly linked list. CLL equals new circularly linked list. Let's do add first 5, add last 10. CL.print list. Okay, let's just do that first. All right. So I'm going to run this. Hopefully this works. We're about to find out. Test it some more. So, okay, so we're traversing the circularly linked list. Didn't print out exactly the way I wanted to, but that's all right, I guess. Actually, I know why. I used, whenever I printed this, I called that print line. So it went to the new line. But so this is good. Add first 5, add last 10. So it should be 5 and 10. That works, right? Let's add first. Let's add first again. Let's do 11 and then add first again, which let's just say 20. And then seal that print list. So we know it's 5 and 10. We're adding to the first, so then it should be 11, 5, 10. Then we're adding to the first again, so it should be 20, 11, 5, 10 for the second printout. I hope. So let's run that. Man, that's ugly. Yeah, but that works, right? So 5 and 10, and then 20, 11, 5, 10, just like I said, right? There we go. Add a print line at the end. Okay. So let's try the remove method. We got to remove first. Let's remove first twice, and then print. So we should be removing 20, 11 for this next list. So it should just say 5 and 10 again. Remove because we moved from the head twice. It does. Okay, that's a lot better printout. So let's see if this works. Remove first. Let's do it 3 times. Obviously, when it prints or when it tries to remove first for that 3rd time, there's nothing in the list, so it should just return null, right? So like nothing it shouldn't error out. It'll say awesome. So the list is empty, which is what we want. Right? Let's print out size of the list plus CLL.get size, just to make sure. And that should work. Yep, size of the list is 0. Okay. All right, so that's coding a circular linked list. I hope you're more than welcome to keep fooling around with the main method and making sure things work. And also, if you have any questions, leave them in the comments and I'll answer them as soon as possible. Or if you need a little bit more understanding of why we coded something a certain way, be more than happy to reach out, okay? Until next time.